Hi, when you're doing inferential statistics, you're supposed to check that certain conditions and assumptions are met. Well, a lot of people wonder what happens when conditions are not met, because a lot of you are taught that when conditions are not met, then you quote unquote proceed with caution. And then you get a result, and then you answer as if nothing happens. So it doesn't feel intuitive, or it doesn't tell you what happens when conditions are not met. So with the thanks of AI, which makes a lot of mistakes, I will show you what happens when conditions are not met. So here we go. I get on ChatGPT and I ask it a statistics question. A researcher wants to know what proportion of a population of voters support a certain candidate. A survey of 15 random voters showed that 60% support the candidate and 40% do not. Construct a 95% confidence interval of the population proportion of voters supporting the candidate. You may recognize this as a one proportion confidence interval, where we would use Z distribution or the standard normal distribution to do the calculation. However, if you remember, in order to do this, we have to satisfy many things, one of which is the large sample size condition, also known as a success failure condition. You have to have at least 10 successes and at least 10 failures. Here what you have 15 random voters and 60% of 15. 60% of 15 is 9. 9 is not 10. And then the 40% that do not support the candidate, 40% of 15 is 6. 6 is not 10 either. The success failure condition is not met, also known as a large sample size condition. But let's see what ChatGPT does. It goes through the numerical formula. It finds P equals 0.6, N equals 15, but it never thought of multiplying 0.6 times 15. It just goes on and on. It finds the confidence interval. It failed to check conditions. So what I do, I asked it about it. Are you sure? Doesn't this method of using the Z distribution require, I guess misspelled there, that there are at least 10 successes and at least 10 failures? Can you check that? ChatGPT admits that it was wrong. You are correct. So it checks NP is greater than or equal to 10, N times 1 minus P is greater than or equal to 10. And it plugs in and they got 9 and 6. Since both NP and N times 1 minus P are less than 10, the large sample size condition is not met. We should not use the Z distribution. So that's what happens when you don't meet the conditions. When you don't meet the condition, you don't get to use a method taught in the intro class. In real life, people have things that don't meet conditions all the time. They just have to use other methods. So for example, in this case, instead of relying on the Z distribution as an approximation of binomial, we're going to use the binomial condition directly. And we do a whole bunch of calculations, and we end up with a confidence interval that's 0.334, 0.866. It's just a different interval now. Same thing happens with inference on a mean. Here's the question. Researcher wants to know whether a certain animal population has mean weight of more than 5 kilograms. She obtained a random sample of 21 such animals and measured their weights. The sample weights are skewed to the right with the sample mean of 5.3 and sample standard deviation 0.6. Tester claimed the population mean is more than 5. This is a one population mean hypothesis test where the sample size is 21, and usually we go for 30 or more. Barring that, we need to know that the population is normal. What did ChatGPT do? It uses the T distribution, which is correct for one sample mean if the conditions are met. But it uses the T test, and it does all the numerical calculations, and it found a p-value. The p-value, blah, 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 is approximately 0.006, since the p-value is less than significance level of 0.05, etc. So I start questioning it. Are the conditions for using the t-test met? Since we're given that the sample is skewed and the sample size is 21, which is less than 30. And check out ChatGPT's answer. It admits that it needs a check condition, and it also knows that the condition is that the sample is approximately normal, or the population is normal or near normal. And it has all of these ways of doing that. Checking the histogram or box plot, visually inspect or use a QQ plot, which is a plot for checking normality. And it correctly said this. In this case, we do not have enough information on the population distribution, and the sample is skewed, so we cannot be completely sure whether the normality assumption is met. So it correctly says that just because the sample is skewed, without knowing more about how skewed it is, to just up and say there's no normality. No, just because it's skewed is not necessarily automatically not normal. So it gives a good answer in terms of checking. But it also tells you what happens when we don't meet the condition. When we don't meet the condition, we just have to use a totally different method. Again, when you don't meet the conditions that you learn in your first year or first semester statistics class, all it means is that you cannot use the methods of that class. You cannot use the t-test for this hypothesis test. But there are plenty of other ways of doing it that you will learn in a more advanced class, like an intermediate or an advanced statistics class. So ChatGPT mentions one of them here, Wilcoxon rank sum test, which does not require the normality assumption. So I asked it to carry out the test, and look how much work it needs. It's still the same no and alternative hypothesis. And by the way, the use of mu less than or equal 5 on H0 is perfectly legit. It's just kind of old-fashioned. All of these calculations, and it sort of runs into the maximum character limit for a response, so I had to ask it to continue. But look at this, the p-value is 0.36. Remember, the other one, the p-value was 0.00 something, very small. This one is quite large. So you end up with a p-value that is quite large, and the conclusion is opposite of the conclusion you would have got if you had gone ahead and used the t-test. So that's the illustration of what happens when conditions are not met. When conditions are not met, it does not mean that you should give up. It also, most of the time, does not mean you should, quote unquote, proceed with caution. Sometimes it means that. Sometimes it means you proceed normally and then you do some adjustment at the end. But other times it means you have to do something else completely. And then the answer may or may not be the same. This is totally opposite of the other answer. All right, I hope that helps. Like, share, and subscribe for more contents. And thanks for watching. Bye.